Hello everyone. As we all know that mathematics is one of the building blocks for all the sciences. So on this channel we are going to discuss the topics of mathematics which are essential for 11th and 12th science, diploma engineering, degree engineering and pharmacy. So if you are a student of one of these branches or one of these streams, this is a must subscribe channel for you because I'm going to discuss all the topics from your syllabus. My name is Dhruti Patel and our today's topic is chain rule. Friends, first of all, let us revise the concept of chain rule. Chain rule is applied when we have a combination of functions, right, which is called composite function. Suppose I have a combination of functions f and g, which I call FOG of x, then it is written as f of gx. Okay, and when I need to differentiate this f of gx, first the outermost function is differentiated and then the inner function. So outer function is f, therefore f will be differentiated. At that time gx will remain the same inside f dash and then g is differentiated. This is the concept of chain rule. Now coming to our function, the function given is y is equal to square root of x square plus 1. Friends, I have seen students getting confused when there is square root. Okay, here it is a square root of a function. So which is the outer function, which is the inner function? We get confused, right? So let us see how the square root is the outer function. Square root of x square plus 1 is formed when fx was taken as square root of x and gx was taken as x square plus 1. So let us combine these f and g. So f of gx will equal to f of what is my gx? It is x square plus 1. Right? And the definition of f says whatever is inside f, we need to take the square root. So here x square plus 1 is inside f. So I have to take square root of x square plus 1. This is our function, right? So which is the outer function? F, and f is the square root here. So whenever you see square root of a function and you need to differentiate that function, that means the square root is the outer function. You must remember this, guys. Now differentiating the square root. So we will remember the formula as square root of something, whatever this something is, right? Square root of something is equal to 1 upon 2 square root of something. Whatever is there instead of dot, we will write it here, right? So here we have x square plus 1 in place of this dot. So square root of x square plus 1 will be differentiated as 1 upon 2 root of x square plus 1, right? So therefore, dy upon dx is equal to nothing but d by dx of square root of x square plus 1. And now the square root is the outer function as I have discussed here. We need to differentiate square root first. So square root of x square plus 1 is 1 upon 2 root x square plus 1, and the inner function is x square plus 1, the gx, right? So gx is differentiated separately. Okay guys, now x square, derivative of x square is 2x and 1 is 0, and therefore I have 1 upon 2 square root of x square plus 1 into this is 2x plus 0. Hence I can write 2x divided by 2 square root of x square plus 1. 2 cancelled out, and therefore my answer is x divided by square root of x square plus 1. This is my final answer. Okay guys, let us take one more example of the square root only. Now y is equal to square root of 1 plus x upon 1 minus x. So my fx is the square root, and which is the outer function, and gx is 1 plus x upon 1 minus x. So again remember, d by dx of the square root is 1 upon 2 the square root. Okay, so therefore dy upon dx is nothing but d by dx of square root of 1 plus x divided by 1 minus x. Now differentiating the square root first, I get 1 upon 2 square root of 1 plus x upon 1 minus x into the inner function d by dx of 1 plus x upon 1 minus x. So that is equal to, see, 1 minus x is in the denominator of the denominator, and therefore I can rewrite this as square root of 1 minus x upon 1 plus x. This 1 minus x will go in the numerator, right? Now here it is division rule, because 1 plus x is divided by 1 minus x. So let us remember the division rule also. Fx divided by gx. Okay, so guys, remember this way, gx is in the denominator, so here in the denominator it will be gx square, and then we will start with gx only. Gx into f dash x minus fx into g dash x. Okay, so this way here in the denominator it will be 1 minus x whole square. We will start with 1 minus x, d by dx of the numerator 1 plus x minus now 1 plus x. I'll have to erase this. Okay, so into d by dx of the denominator 1 minus x. Okay, now 1 plus x, derivative of 1 is 0, x is 1. Here 1 is 0, x is 1, so it will be minus 1 here because I have minus x, right? So that is equal to 1 upon 2 square root of 1 minus x divided by 1 plus x in the bracket 1 minus x into 1 plus x will become 1 minus 1 plus x into 1 minus x will become minus 1 divided by 1 minus x whole square. Now see here, square root of 1 minus x upon 1 plus x can be distributed square root of 1 minus x upon square root of 1 plus x, and square root is nothing but 1 by 2 power, guys. So this will equal to 1 upon 2 into, I have 1 minus x raised to 1 by 2 upon 1 plus x raised to 1 by 2. Here in the bracket 1 minus x. This minus will combine with this minus and will become plus. So plus 1 plus x divided by 1 minus x whole square. These minus x plus x cancelled out. 1 plus 1 will be 2. See here in the denominator I have 1 minus x, and in the numerator also I have 1 minus x. So powers will be combined. So that is equal to 1 by 2. I have 2 in the numerator. This is going to combine with this 1 minus x whole square in the denominator. So 1 plus 1, 2. I have 2 here divided by this 1 plus x raised to 1 by 2 into 1 minus x raised to 2 minus this 1 by 2. Okay, it is 2. Please make sure you understand this. That is equal to this 2 cancelled out. 2 minus 1 by 2 will be 3 by 2. Okay, so I have the answer 1 upon 1 plus x raised to 1 by 2 and 1 minus x raised to 3 by 2. This is my final answer. I hope you have understood, guys. If you don't understand this example, You must watch this video again, okay, until you understand this, because I have given one more example with the same method for your practice, which is here. This is for your self practice. If you are not able to do this example, please write in the comment box. I will make a video on these examples also. Okay, goodbye everyone.